Hi dear students, so welcome to today's Brainiacs Capsule. So we will be continuing today also the nucleophilic addition reaction part 2. Okay, so we will discuss some of the important reactions that comes under this nucleophilic addition reaction. Okay, and we know that this is mainly given by whom? Aldehydes and ketones. So let's start with the question. Yeah, here. So the question here is when 2 mole of alcohol, okay, reacts with a single mole of ketone, what will be the product? Okay, so let's try to understand and analyze this question. Now you have a 2 mole of alcohol, so you can take any alcohol, it would be fine. So I am taking ROH, general formula I am taking. Okay, 2 moles are there. So right now I have taken how much mole? 1 mole. Now I am making it reacted with the ketone, RC double bond OR. This is a fundamental ketone. If you put a substituent alkyl groups, you can get the necessary ketone. So they just mentioned it's a ketone. So RC double bond OR. Now what will happen actually, sir? So here I can say here always aldehydes and ketones, they undergo nucleophilic addition. So what will happen? First step is this will polarize in such a way that carbon will have positive charge. And we know that the octet of oxygen is complete. So therefore who will come first and attack? The nucleophile will only come and attack. So the next step is from alcohol we need to generate a nucleophile. So how we can generate nucleophile? Break the bond, because alcohols are also acidic. So I can easily say RO minus and H plus can be generated from alcohols. And who is the nucleophile? I can easily say RO minus would be the nucleophile and it will attack the positive charge of the carbon. Now what will happen? When attacking means it will donate its pair of electrons to the vacant orbitals of the carbon and you will get a compound like this. Clear? Now what will happen? You have H plus is also there. So the H plus will attack whom? O minus. So what you will get fundamentally? You have a compound where the carbon atom is connected to alcohol OH group and a methoxy group. It's not methoxy, we can say alkoxy group. Whenever the carbon atom has one alkoxy group and also the OH group on the same carbon, we fundamentally call that as a hemiketol. Why we are saying ketol? Because the starting compound is an ketone. Suppose instead of R, you have starting compound as an aldehyde, then we say hemiacetol. We will call that as hemiacetol. But we have taken here ketone, we say it is a hemiketol. Clear? So what is the mechanism happened here? We know that the nucleophile attacked the compound first, so we say nucleophilic, and during the reaction the double bond changed from double bond to single bond. You can see here. So we say the mechanism followed here is nucleophilic addition reaction. Clear? Now, but the reaction is not stopping. Why? Because you have one more molecules of alcohol waiting. You have started with 2 moles. So in question, whenever they say 1 mole alcohol with 1 mole ketone or 1 mole alcohol with 1 mole aldehyde, then hemiketone or hemiacetal will be formed. But whenever you have excess alcohol or 2 moles of alcohol, what will happen? Again, I can say this will undergo further breakage to create one more nucleophile and H plus. But now the students will have a doubt. Sir, there is no C double bond or carbonyl group. So what will happen, sir? Please understand, in this particular compound, O has 2 lone pairs present here. Okay. So what will happen? This is an electron rich site. So I can easily say the H plus will easily come and attack this lone pair. Okay, H plus will come and easily attack the lone pair. Now some students may ask, sir, what will happen if this alkoxy group has also 2 lone pair? If OH attacks here. So please understand, if OH attacks here, the removal of alcohol is very difficult. But you can say here what is happening is, listen, when H plus attacks this oxygen, the one of the lone pair of oxygen is lost and it will get positive charge. We know that oxygen with the positive charge is highly unstable. So this pair of electrons will move towards oxygen atom, and as a result, what will happen? The bond density would be like this. You can see I am drawing like this. Okay, so electron density is more near to the oxygen and the bond will undergo breakage here like this. So what will happen because of that? I can easily say it will remove a water molecule. what it will do? It will remove a water molecule as H2O. That's why I told here, if it same thing happens, the alcohol needs to be removed. But we know water molecule is easy to remove because it has two hydrogen atom which is having a less molecular weight. Understood? So elimination or dehydration occurs, and what will happen? You will get a positive charge, a carbocation over here. And I can say this is also stabilized by resonance because this oxygen has two lone pair, and this can enter into resonance with this structure and it is stabilized by resonance. And in the next step, we know that we have the nucleophile Ro minus, which will come and attack the positive charge, and in the same carbon atom now you are getting two alkoxy groups. Whenever in the same carbon atom two alkoxy group comes and two alkyl groups are present on the same carbon, we say that as a ketol. But instead of R, if you have an H, then we call that as an acetol. But can you tell me what is the reaction happened in the second phase? I can easily say during the second phase, OH, which is a strong nucleophile, OH is a strong nucleophile, which is replaced by another strong nucleophile, Ro minus. So one of the nucleophile is substituted with another nucleophile, OR. So I can say the reaction happened here is nucleophilic substitution reaction. So in this particular reaction, what you need to remember, very, very important, I can easily say 1 mole alcohol reacts with 1 mole ketone. If this is the case, I can easily say the mechanism is what, sir? The mechanism is, I can easily say the mechanism is NAR, nucleophilic addition reaction. Okay, but whenever you are taking 2 mole of alcohols or excess of alcohols with 1 mole of aldehyde or ketone, anything you can take, 1 mole of aldehyde or ketone, then the mechanism followed would be, I can easily say, first nucleophilic addition reaction followed by what will also happen? Nucleophilic substitution reaction. This is very important. So please, they may ask this question, when excess of alcohol is taken, if you are making it react with aldehyde or ketone, what is the mechanism? NSR followed by NAR, NAR followed by NSR, it is successive NAR, successive NSR, like that they can ask. So please remember, it is NAR followed by NSR. Okay. So tell me, sir, what is the answer here? That is most interesting part, right? So answer here is, I will get a ketol. Okay, if I have taken aldehyde, it would be acetol. If it is 1 mole, I may get hemiketol or hemiacetol. I hope you understood the idea. Okay, yeah, let's go with the next concept. Or next question. Yeah, we have the next question in front of you. All of you, please go through the question. The cyanohydrin of the following compound on hydrolysis gives a compound that can show optical isomerism. So that means, what is the meaning of this question? It means any of this compound, when it react with the when it react with what you say, or the when it react with the HCN, okay, it will give you cyanohydrin. Okay, and they need to know which of this compound will give a cyanohydrin that shows optical isomerism. Okay. So the question here is, cyanohydrin of the following compound on hydrolysis gives the compound can show optical isomerism. So here I can easily say that here the first compound that is taken here is, listen, HCHO. Okay, now how the reaction will happen, I will help you. So first, the meaning is it should react with the HCN to create the cyanohydrin. So HCN means it will split up like H plus and Cn minus, correct? You can see here. Now we know that this will undergo polarization first. So O minus, here plus, and you have hydrogen. Okay, now who will attack first? I know that the nucleophile Cn minus will attack. So what you will get, HC, here Cn, okay, here H, and you will get O minus here. Okay, so this O minus will be further attacked by whom, sir? You can easily say this would be further attacked by H plus. So my final compound is HCH. You can see here Cn and OH. So this is one of the cyanohydrin. Why it is called cyanohydrin? Because the same carbon atom is carrying OH and CN. But please remember, this is not optically active. Why? Because the four valencies needs to be what? Indifferent whenever an optical activity occurs. But here you can see the carbon is having 2 hydrogen. So I can say it is not optically active. Now you don't need to do optically inactive. Now I can easily say I don't want to try with other option like maybe option 3. Why? Because it has 2 CH3 groups. So surely the obtained compound will not show optical isomerism. So the only option here is option 2. So with that I can finalize the answer. Option 2 would be my correct answer. Clear? Why I am choosing that? Because in HCHO you can see 2 hydrogen atoms are there. Here 2 CH3 are present. So surely it will not give you a compound that shows optical isomerism. Correct? So you can say here CH3CHO reacting with HCN, it will split like H plus and Cn minus. You can see H plus and Cn minus. And the first attack comes from the nucleophile to the positively charged carbon. You can see like, okay. Then what will happen, sir? Cn will come here and H plus in the next step will attack the O minus, and here you are getting a compound that is 4 are different valency. One is CH3, one is OH, one is hydrogen and one is cyanide. So that means this carbon is a chiral carbon. That means it show optical isomerism. Whenever a single chiral carbon is present in a system, surely that compound will show optical isomerism. Take my word. Okay. So I hope you understood. Now we are coming to the last question. Arrange the following compound in the decreasing order of reactivity towards nucleophilic addition reaction. Okay. So again we know the rate of nucleophilic addition reaction depends only on the first step. That means how much amount of positive charge is coming on the carbonyl carbon, that much fast the nucleophile can come and attack. Okay. So we need to see in which of the following 4 compounds the carbonyl carbon has more amount of positive charge. Now when I am analyzing this, I can understand here. Listen, the first compound, if you see here, it has positive charge present here, but this positive charge has problem because CH3 group is a plus I group, so it will donate its electron to here, and the benzene ring is present, so it will the positive charge may enter into resonance with this benzene ring. So I can say here the availability of positive charge is very less. So the nucleophile cannot attack this compound very effectively. Okay, I hope it is clear. Now coming to the second compound, you can see here you have 2 alkyl groups connected, and we know that both alkyl groups have plus I effect. So both of them will donate electron to the positive charge. Again, it is decreasing the magnitude of the positive charge. Correct? So I can say compared to 1, 2 has little more reactivity. Why? Because in the first compound you have 1 resonance is present and 1 plus I effect. Here both of them have plus I effect. Okay. Now the third one I am taking, it's a very good question. Here again the positive charge can enter into resonance with one of the benzene ring, but the other side hydrogen is there, the inductive effect is 0, nothing is there. So I can say its reactivity is much better, much better compared to above 2. Why? Because in the above 2 both side have problem, both side has issues, but in the third one only the one side is making the positive charge to make into or forcing the positive charge to enter into resonance here. Now coming to the last option, you can easily see there is a minus I group is connected, chlorine. So what it will do, it will pull the electron in this direction. So positive charge keep on increasing here. That means this one will have the highest magnitude of positive charge. So I can easily say the more reactivity would be given by whom? Fourth one, then we have third one, then we have second one, then we have first one. This would be my rate of reactivity. Clear? So I can say my answer here is which one, sir? I can easily say my answer here is 4, 3, 2, 1. That is option 1 would be my correct answer. Clear? So I hope you understood the concepts. Okay. So we have discussed 3 important questions from the concept of nucleophilic addition reaction. Tomorrow we will discuss some more concept. For example, there is a concept called nucleophilic addition followed by elimination. how that happens, on which condition it will happen. We will discuss those scenarios tomorrow. Okay, those who have liked the channel, you can subscribe it. And if you feel you need more support, you can contact Brainiacs Classes, which is one of the leading institute for NEET coaching in Coimbatore. Thank you.